So shall we start?
Yes, ma'am.
Okay, so I think we have completed day 1, and I talked on descriptive statistics, right? And we have seen that how we can apply descriptive statistics using Excel. So today is the day 2 where I will talk about the chi-square test, right? So give me a second. I'm firstly sharing my screen. And I think we have shared already the Excel sheet in the group. I hope you people have received it. I think, hello. You people have received the sheet? I'm waiting for your confirmations. Have you people received the sheet? Yes, Sunita ma'am. Have you seen it? Okay.
Yes, ma'am.
Yeah, thank you. So I'm sharing my screen. Give me a second. Yeah. I shared my screen expecting you. Please tell me whether it is visible or not.
Visible, ma'am.
Yeah, thank you, ma'am. Okay, so give me a second. Yeah. So we are starting with the conceptual aspect firstly, and then we will see that how we can use Excel for the chi-square test, right? So the day 1 when I started with the descriptive statistics, at the same day I told you we can divide statistics into the 2 parts. First one is the descriptive statistics, and second one is the inferential statistics. So descriptive statistics, as I said, we already discussed. Now onwards, I am starting with the inferential statistics. Anyone who is having any idea about inferential statistics? Anyone who can tell me what do you understand by term inferential statistics? Sunita ma'am, I think there is some problem at your end. If you are not speaking, I request you to please mute yourself. Yeah. Yes. Anyone who can tell me what do you understand by term inferential statistics? Anyone, if you're not knowing, please tell me so that accordingly I can proceed. Anyone? I hope you people are listening to me. Yes or no? Shall I start or not? Participants? Okay. Means you people will only give me the... Okay. You people are giving me thumbs up, but thing is that once I'm sharing my screen, I cannot see your anything, whatever you are showing me through the emojis and all. So please, if possible, interact. Fine. So I'm assuming I have to explain you the term inferential statistics. So I'm starting. When I talk about inferential statistics, we can say whenever we want to infer about the population using the sample, we can call this type of statistics inferential statistics, right? So in research, generally what we are doing, we are collecting the data from the sample because many a time it happens, population size is very large and it is not possible for us to collect the data from each and every unit of the population. So what we do, we are taking a group of people, which is known as sample, which is representing the entire population, right? So that way we can say inferential statistics is nothing, but we are doing the study of the population using the sample, is known as inferential statistics. And I can say we are studying the population parameters using sample statistics. So there are 2 terms comes, parameter and second one is statistic, right? So parameter is in terms of population and statistics is nothing but it is related to the sample. So what is parameter in the statistics? These are nothing but are the characteristics of the population and sample. When I'm calling the sample characteristics, we can give it name as a statistic. This is a technical term. Population characteristics is known as the parameter. So when you are studying the population characteristics using the sample characteristics, we can call this kind of statistics as inferential statistics, right? And for this, generally, we are going for the hypothesis testing. So maybe you can recall when we are making the hypothesis, generally we are saying that there is no significant difference in the mean of one group and other group. We are saying there is no relationship between the variables. So in some way, we are interested in looking the parameters or the statistic only, right? So we can say we are making the assumptions, because hypothesis is nothing but it is an assumption. So we are making an assumption for the population parameters, which we are testing using the sample statistic, right? I hope I'm clear what I said.
Yes.
Yeah, thank you, ma'am. So moving ahead, in case of hypothesis testing, we are making the hypothesis. Usually we are making null and alternative hypothesis, right? Null generally we are representing by HO or H0, we can say it, right? And alternative we are representing by H1 or HA, right? So this is the representation of the null and alternative hypothesis. Question comes, what is null hypothesis? So null hypothesis is what? Null hypothesis is nothing. When we are saying null means void. So means when I'm saying nothing like this is existing, when I'm saying there is no significant difference in mean of group N1 and group 2, that means I'm nullifying that the two groups mean are different, right? So if my data is not supporting the null hypothesis, I need to go to conclude something else, and that something else is known as my alternative hypothesis. Means the opposite of the null will always be known as the alternative hypothesis, right? Till here I'm clear. Shall I proceed now?
Yes, ma'am.
Yeah. Now we can say we need to use certain statistical tests to test the hypothesis, and we can divide these tests into the two categories named as parametric tests and the non-parametric tests. So when we say parametric, so I think I'm not discussing the meaning of parametric today. We are starting this kind of statistics from tomorrow. So I'll take this terminology from tomorrow. Today I'll discuss the non-parametric tests. So when we call non-parametric test, means the name itself is indicating non-parametric means the tests which are not based on the parameters, right? So the tests which are not considering the parameters of the population or all the tests which are not considering the population parameter come under the category of non-parametric tests, right? Other way around, we can say when we are not considering the distribution of the data, especially the normal distribution of the data, in that case, the tests which we are using are known as the non-parametric tests. So we can say non-parametric test is are the tests which are not considering the population distribution, and also which are based on the categorical data. So there are two things. First thing, no consideration of the normal distribution. Second is the categorical data will be used in case of non-parametric tests, right? So in this category, we are having so many different tests. For this particular FDP, we are talking about the chi-square test. So now onward, I will talk on the chi-square test. I hope till here I'm clear about the non-parametric test definition. No doubt. Shall I proceed?
Yes, ma'am.
Thank you. So moving ahead, talking about now chi-square test. So first thing, it is non-parametric, right? Second thing, it is based on categorical data, right? That means based on nominal data especially, and ordinal also we can take here, because categorical data considers or consists of the two types of variable, nominal variable and ordinal variable. And I think meaning we have already understood of nominal and ordinal, right? So we can say the chi-square test is a non-parametric test because it is not considering the normal distribution of the data, and it is using the ordinal data or nominal data, right? Second thing is that generally when we are interested for finding the uniform distribution, uniform distribution of what? Uniform distribution of frequencies. Because in case of categorical data, only possibility is that we can have the frequencies or counts, right? We cannot go for getting the value of the variable, because we know nominal data is nothing but it is a data which can help us to categorize. Say for example, if I'm saying gender, gender is a nominal scale data, and here we know we can classify this variable into two categories, male and female category. And in case of male and female, I cannot assign any value here. In case of gender, male is suppose one category, so there is no value of the male. There will be the count always, right? So I can say maybe I am having 32 male and maybe suppose 33 female in my data. It is clear, right? That means whenever we are talking about the categorical data, we will be only having the count or frequency of the data. So chi-square test is dealing with the categorical data. So the purpose is very simple. Here we want to see the distribution of the frequency. That means this distribution we are expecting, this should be the normal distribution, right? Clear to everyone till here? Shall I proceed?
Yes, ma'am.
Yeah. Now we are talking about types of chi-square test. We can divide chi-square test into the two categories. First one is the goodness of fit test, and second one is the independence of attributes. Other way round, or the other name of this is test of association. Right? So these are the two varieties in the chi-square test. Firstly, I'll explain you the goodness of fit. So goodness of fit chi-square test is based on one categorical data. So when I'm having a single categorical variable, I'm talking about the goodness of fit test, right? Now, here, please understand this particular terminology very carefully. I am saying I will be having a single categorical variable, but this variable can have multiple categories, right? For example, if suppose I want to collect the color preferences from the respondents, right? Say for example, we are having certain color categories here: black, white, green, purple, and maybe yellow, right? And suppose I have done a survey on 100 people, right? And I'm asking them, out of these 5 colors, which color they are liking, right? So maybe 30 are saying they are liking the black, 25 are saying they are liking the white, 15 are saying they are liking the green, then 20 are saying they are liking the purple, and 10 are saying they are liking the yellow. So you can see the variable which I am having is the color preference. That is a single variable. But in this, I have given a multiple color categories to the people. So this, in this variable, we are having total 5 categories of the color. So here you need to understand we can have the single categorical variable with the multiple categories, right? And here what I'm looking for the distribution of these frequencies should be same throughout all the frequencies, right? So you can understand here, out of this is the total of the count or total frequency, right? Which is coming as 100. So my expectation is what? It should be same throughout. So 100 divided by how many color categories I am having? 5. 100 divided by 5. This should be 20, 20 and 20 throughout. This is what I am expecting. So that way we can say whenever we are talking about the chi-square test, we are comparing the observed and expected frequencies, right? So what we are looking for, that whether these two frequencies are similar or not, whatever the people are saying or whatever we are observing from the survey, whether this count is same what I'm expecting or not. So that way you can see this is known as chi-square goodness of fit. And those who are knowing the formula of chi-square test, they know this thing. Formula of chi-square test is based on these two things only, O and E, that is observed frequency and expected frequency, right? Till here I am clear. Any doubt so far?
No, ma'am.
Fine. In this case, if we are making our hypothesis, so generally we are writing there is no significant difference in the observed and expected frequencies. This will be our null hypothesis. An alternative will be opposite to this. There is a significant difference in the observed and expected frequencies. Fine. So this was about the goodness of fit test. Now moving to the second category, which is test of association or independence of attributes. In this case, we will be having two categorical variables. So I think you just observed, in case of goodness of fit, we will be having a single categorical variable. But in case of test of association, we will be having the two categorical variables, right? So we want to see the association between two variables. Means it is like when we talk about the correlation. In correlation, we are looking for the relationship or association, but that relationship will be in generally the numeric variables. But here, when we talk about the chi-square test, we are looking for the association between the two categorical variables, right? Whether the two categorical variables are independent of each other or whether they are having any association between them, right? So we can say categorical variable here is also known as attributes. We are studying the attributes of the particular object. Say, for example, I am studying whether the political or the voting preferences is independent of gender or not, right? So voting preferences and gender are the two characteristics or the two attributes which we are studying, and we want to see whether there is any relationship between them, association between them or not, right? Clear? I hope this is clear.
Yes, ma'am.
Here there is a term comes named as contingency table. Anyone who knows what is contingency table?
It is a two-way table. Yes.
Table called as a contingency table, ma'am.
Very correct. It's a two-way table. Very correct. It's a two-way table, or it is also known as cross tabulation. Right? So two-way meaning is what? Because we will be having the two categorical variables with us in case of this particular category of the chi-square test. So one variable we are keeping in a row, other variable we are keeping in a column. So that is why we can say it's a two-way table or it's a cross tabulation. So in a cross category, we are writing the values of the or the count of the variables. Suppose I am saying voting preference. So please don't mind. I'm writing certain names of the parties. So these can be anything, right? And I'm asking from the people and I'm considering their gender, right? So suppose So this is a survey of total 170 people. Out of them, 80 are male and 90 are female. You can see here, male 30 are going with the BJP, 27 Congress, 23 up. Similarly, 40 BJP female, 22 Congress, and 28 up. So that will be 90. So this way you can see this is the cross tabulation. The one variable, that is the voting preferences for the various different the parties, right? So your party preference also we can say it. So that way one variable I have taken in a column. So the category, how many categories I am taking, that is listed in the columns, right? Similarly, second variable is the gender. So gender, I am considering only two categories, male and female. So that is listed in a row. And in the combination of these two, we can see these are the counts. This way, this is a two-way table. I can also write the total column wise. Clear? Done? I hope it is clear.
Yes.
Yes. Yeah. So this way we have we have written here the contingency table, and in both the cases, whether it is a what I can say, goodness of fit case, or whether it is a test of association case, in both the cases, same formula you need to use. Only the difference comes when we are calculating the expected frequencies, because always the frequencies we will be having are known as the observed frequencies. For these frequencies, we need to calculate the expected frequencies, right? So in case of the first category, which is the goodness of fit, I already told you how to calculate the expected frequencies. So which is what? If I want to write the formula, I can say E, or expected frequencies, are nothing but it is an average of observed frequencies. Yes or no? Done? Then in case of this second category, E is row total into column total divided by grand total, right? Clear? Is it fine?
Yes.
Now, if I talk about the hypothesis in case of second category, so generally we can say, as we want to see the independency, we can write there is no association between categorical variable 1 and categorical variable. Done? Or you can say categorical variable 1 is independent of categorical variable. This is also possible to write. One in the same thing. Okay?
Yes.
I hope it is clear.
Yes, ma'am.
Fine. So this is about the conceptual clarity of the chi-square test. I hope, no doubt. Shall we proceed and see that how we can use now Excel for these things?
Why do we use goodness of fit, and where to use it?
When you are having a single categorical variable and you want to see the frequency distribution of that, whatever the categories you are having. So in that case, you are using it. You want to see whether the frequencies are fitting properly or not.
Okay.
So it is totally depending upon of the objective of yours, right? So in our research, if your objective is very clear, is in somewhere you are having only a count and you want to see that count is distributed throughout all the categories in a uniform manner or not. So you will go for the applying of the goodness of fit test of the chi-square category.
Okay. Thank you.
Yeah. Okay, any other doubt, or shall we proceed now? And afterwards, we are taking the questions. As you say, shall I proceed now? Shall we proceed?
Yes, ma'am.
Yeah. So requesting you to open a sheet given by me named as Demo GOF. Open, everyone.
Yes, ma'am.
Let me clear my sheet. Maybe we have done the things priorly. Yeah. So I think this sheet I have provided to every one of you, right? Done?
Yes, ma'am.
Now you need to understand the situation which I have mentioned here. This situation is telling us a table shows the number of people absent on particular days in a week, right? So maybe this is a data of any school or the college. In that, these are the count which have been observed by the management or maybe the authority. These are the absenteeism count on a particular day. So in a week, 5 days are listed here, Monday to Friday, and the number are nothing but these are the count, or these are the number of the absenteeism on these particular days. Is it clear?
Yes, ma'am.
Here we want to see whether this absenteeism is, whatever the absenteeism is mentioned here, is uniform throughout all the 5 days or not, right? So firstly, let me let me check. Okay, I'm writing firstly the formula here. This is the formula which can help us to perform chi-square test. This formula generally we are using manually, right? So here you can see whether it is the manual calculation or whether we're talking about using the Excel. In both the cases, we need to have both the frequencies, observed and expected. Always the given frequency is treated as an observed frequency, and we need to here calculate the expected frequency, right? So I think I already told you, in case of what? In case of goodness of fit, the expected frequency is nothing but this is the average of the observed frequency, right? So here I can calculate average. I think average function is known to everyone, so you can use it. And in that case, I'm providing the range, right? And then closing the bracket, pressing enter. And I can drag it throughout all the cells. So that way you can see expected count is coming as 100, 100, 100. I hope it is easy to do. Everyone has done this.
Ma'am, can you repeat it once?
Yes, ma'am, repeat, ma'am. And how did you get that sum of symbol, ma'am?
Absent. Which symbol, ma'am? This is not necessary to write. If you wish to enter it, you can go to the insert and from symbol you can take.
Okay.
Already means what I can say, it is not important for us to know, but I think I want to show you this is the formula which we are using here to calculate the chi-square test.
Okay, ma'am.
Although Excel is using the functions, right? So I think functions I have already given you in your sheets.
Yes, ma'am.
Right? So I'm writing, firstly, give me a second, I'll show you. I'll write firstly my hypothesis. There is no significant difference in the observed and expected counts throughout 5 days. Then there is no significant difference in the absenteeism or absenteeism counts throughout 5 days. This is my null hypothesis. Alternatively, I can say there is a significant difference in the observed and expected absenteeism counts throughout 5 days. This is the null and alternative hypothesis. Now coming back, and if you want to calculate expected frequency, I think everyone knows the function is average. You need to use this, right? You can check it. Done? Done? Shall I proceed? Yes. Shall I proceed? I'm expecting your answers. Please say something. Yeah.
Yes.
Done. So we have calculated expected frequencies. Now you can see, as I already told you, that Excel is based on the functions, and other than that, there is a add-ins I have already told you to add that we have done on I think Saturday, that we have completed. No, Friday we have completed that. So you can go to the data tab and click on the data analysis, right? So once you will click on that, you would be able to see all the tests which are listed are alphabetically listed, but you can find in the list, you will not able to see the chi-square test. Chi-square test is not available in that add-ins also. I hope you people have checked it. Checking done.
Ma'am, can you repeat it once, sir?
From where I need to repeat?
After this 100 number comes, no expected frequency.
No,
After
I haven't did anything. I just told you people, go to the data tab. After going on a data tab, if you have added that analysis tool pack that I've told you on Friday, you can click on that and you can check.
It's not coming.
There is no chi-square test listed there. This is what I said.
Yes, ma'am.
Right? You people have checked it.
Checked it, ma'am.
Right. So meaning is that we need to be dependent here on the functions. So for the purpose, I have given you the functions. Okay, clear? Shall I proceed? Is it clear?
yes, ma'am.
Yeah. So if it is clear, now as we know, we are using these softwares for getting the p-value, right? So means if I will report, or either if I want to reject or accept my null hypothesis using the p-value, I can do so. So you can see the function which I have provided you, the first one, which is for the p-value, it is written here, right? Now I'm using this. So I'm writing here, I'm firstly calculating the p-value. So for execution of the function, I need to put the equal sign. So in a blank cell, I have kept a equal. I'm typing CHIS. You can see the various functions are available. From the list, I'm selecting the last one, named as CHISQ.TEST. Maybe using I don't know how many of you are using which version of the Excel. In the previous versions or in the older versions, maybe you can find the function named as CHISQ.TEST, means without the dot. Even then it will work same, right? So this is the function you need to use. After selecting the function, you can see it is asking you to provide the actual range and expected range. So you need to give the actual range, that is the observed frequency count, like this. Put a comma and select the expected frequency count and then close the brackets. So this is the only thing you need to do to get the p-value. I hope it is clear.
Yes, ma'am.
Now press enter. So this is the p-value we are getting. according to the thumb rule says if the P is less than your level of significance, in that case, you reject the null hypothesis. Opposite to this, if P is greater than level of significance, in that case, you need to accept the null hypothesis. So you need to check here, what is your level of significance? So I think generally we are testing the null hypothesis in the social sciences at 5% per level of significance. So suppose I'm assuming I'm testing my hypothesis at 5%, right? So in my case, you can check. This is 0.02 and 5% meaning is what? This is 0.05. Yes or no?
Yes, ma'am.
So you can compare now. So you can make a comparison. You can say it is less than 0.5. So if your p-value is less than your level of significance, in that case, we suggest to reject the null hypothesis. Means we can say our data is not supporting the null hypothesis. And when data is not supporting the null hypothesis means you need to make your conclusion on the basis of the alternative hypothesis. So what you can say, there is a significant difference in the observed and expected absenteeism count throughout 5 days. Clear? Clear, I hope.
Yes, ma'am. Just one doubt, ma'am.
Yeah.
For chi-square, you selected for the p-value, ma'am. Sorry. For p-value, you selected the columns. That is the number columns you selected. It came from B3 to B7. And then in between, what is the sign that you put, ma'am?
Comma.
Comma. Okay.
I think formula itself is indicating you need to separate these two arguments by comma.
Okay, ma'am. Thank you.
Yeah.
Ma'am,
Yes.
I have a doubt, ma'am. Ma'am, while doing the manually, while we are teaching our children, they are doing the formula manually, like they are summation O minus E whole squared divided by E. Likewise, they are calculating their table value.
Yeah, that is, there are two rules of acceptance and rejection of the null hypothesis. One is based on p-value. Second one based on that manual calculation where we are comparing our calculated value using the critical value.
I mean that I have a doubt, ma'am. Whenever we will be finding out degree of freedom, as well as we'll be calculating that we'll be calculating one value. Calculated value is there, and by seeing the degree of freedom, we have the calculated value. By checking it, we are finding out the table value.
Using so we have two parameters, using the level of significance and degrees of freedom, we are getting the critical value or table value.
So my concern is when the table values, when we can say significant, non-significant, when the table value is less than the calculated value, we said significance, or calculated value is more than table value. That confusion I have, ma'am.
Okay, so when your calculated value is less than your critical value, right? In that case, you accept.
Yeah. I have that is significant. That is significant.
Yeah. No,
okay.
This is not significant. You are accepting the null hypothesis.
Okay, ma'am. Actually, in that our studies, ma'am,
yeah.
Each column will be writing significant, not significant. Then later on, together based on the significant, not significant, we'll be accepting and rejecting.
Yeah. So always, I think at day one, I told you, always we are keeping or checking the null hypothesis, right? So when your calculated value is less than your critical value, you are accepting the null hypothesis. Opposite to this, when calculated value is greater than the critical value, you are going to reject the null hypothesis. So this is a case which is based on the critical value. So there are two types of decision. One is based on the critical value. Second one is based on the p-value.
Okay, ma'am. So
you can note down, this is the rule. This is the rule in case of manual calculations.
Come again, ma'am. Please, ma'am. 1 minute, ma'am. Come again, ma'am. Well, table value is less than the critical value.
Calculated value is less than table value, or calculated value is less than critical. Critical meaning is table. Critical and table is one and the same thing.
Okay. Table value is less than the calculated value. It is we have to reject our null hypothesis.
Wait a minute. I will tell you, always keep only one thing in your mind. Either tell this rule using means I always understand means whenever I understood this rule, I always say calculated value is less than critical value. So I'm comparing, I'm keeping calculate fixed. I'm saying calculated is less than critical, so we are going to accept the null hypothesis. Calculated is greater than critical, I'm going to reject the null hypothesis. Get it?
Okay,
Yeah.
ma'am.
So always memorize this thing in a one way only. Similarly, p-value less than level of significance, reject it. Less than or greater than level of significance, accept. So this is opposite to each other.
Okay, ma'am. Either we can see the p-value or you can see the calculated value. Both the way we can reject or accept. Yes, ma'am.
More technically we are talking about, so we are generally calling it statistic value and critical value. This is generally used by in the books and all. They are not calling it as calculated, they are calling it as a statistic value. So chi-square statistic, we are comparing it with the chi-square critical.
Okay, ma'am. Value and critical value. Okay, ma'am. Thank you, ma'am.
Okay, so I think according to the p-value rule, we have done this. So as ma'am said, if you wish, you want to calculate the critical value and calculated value also, here I have given you the functions for both. I hope you can see. So do I need to tell you, or you want to go with the p-value only? Yes.
Ma'am, you can go with one example.
Example, so I will take only this example only, but I will tell you how you can calculate using those functions. So do I need to tell you? This is what I'm asking. Shall we go ahead? It is like means why I'm asking, because thing is that sometimes people are not much comfortable in memorizing all the rules, right? So those who are okay with the p-value rule, because in the other softwares generally we are always accepting or rejecting the hypothesis using the p-value, but sometimes it happens we need to report the test value also, means what is the t-value, what is the chi-square value. So for the purpose I have given you these two different functions also. Okay, so I'll calculate here chi-square value. So calculating chi-square here. Done. So for calculating the chi-square value, this is the function. So here what you need to do, CHISQ dot INV dot RT. This function you need to use, right? You can see this is asking you two things. First one is the probability and second one is the degrees of freedom. Probability means we have just calculated the probability, which is this value, right? So select wherever you have calculated the p-value. Then put a comma. Degrees of freedom will be n-1. So how many categories here mentioned? 5 days are mentioned. So 5 minus 1, which is 4. Done? Is it clear? Clear?
Yes, ma'am.
Yes, ma'am.
So this is the calculated value. Now, if you want to get the critical value, critical chi-square value, if you want to get, so we can use the function called CHISQ dot INV. This is asking you again probability, but in this case, which probability you need to provide? You need to provide the confidence level. So confidence level will be what? If the level of significance is 5%.
0.05.
No, level of significance is 5%. So confidence level will be what?
95%.
95 means 0.95 you need to supply here. Degrees of freedom will be 4 and then close the bracket. Done?
Ma'am, how that 0.95 came? Can you tell once?
Level of significance is 5%. So if level of significance is 5%, confidence level will be 95%. There is a relationship between these two. So 1 minus level of significance will give you the confidence level percent. Done? So we are getting it as 9.48. So now those who want to conclude only, please, they can pay attention, because sometimes it happens. Maybe it can confuse you also. So you can compare. Now your calculated value is greater than critical value, right? So in that case, you need to reject the null hypothesis, and you can make the comparison. In our case also, we have done this. In case of p-value also, you have rejected, and here in case of this also, we are rejecting. So meaning is very simple, whether you are opting this rule or whether you are opting this p rule. In both the cases, your results will be same. There will be no discrepancy. Here, yes.
Yes, ma'am.
So shall I proceed if it is clear to everyone?
Yes, ma'am. You can proceed.
Fine. So
Yes.
this was about this chi-square goodness of fit test. Now, one more practice sheet I have provided you with the GOF name. You can use this sheet for your own practice purpose. So if you wish to practice the chi-square goodness of fit, you can apply the chi-square test on this, right? Now moving to the third sheet named as demo IOA. Done. In your case, maybe it will be protein bank.
Please wait, ma'am.
Sorry.
Please wait, ma'am.
Yeah. Okay. Once you people are ready, please tell me, then I'll proceed. Done. Shall I proceed?
Yes, ma'am.
Okay. So now we are shifting or moving to the next chi-square test, which is test of association or independence of attributes, right? Okay. Now you can see I have provided you two columns named as wealth or wealth status and the graduation status, right? We want to see whether these two variables are associated with each other or not, right? Clarity? What a clarity?
Yes.
So now, if I want to see whether these two categorical variables are associated with each other or not, so as you can first see, both the variables are categorical. One variable is the wealthy status. So you can see there are certain categories given of the wealthiness status of the respondents, right? Similarly, if you want to see the second variable, which is graduate status, there also you can find there are two categories, yes or no, whether the person is graduated or not graduated, right? Now we want to see whether these two are associated or independent to each other. So firstly, we will make our hypothesis here. Anyone who can help me to write the hypothesis? Yeah.
There is no difference between this wealthiness and graduation.
Okay. Anyone else?
Ma'am, there is no association between wealth and graduation.
Very good. There is no association between wealth status and graduation status. Right? Other way around, I can say, or alternatively, I can say, there is an association between wealth status and graduation status. I hope it is simple to understand and clear also. Yes?
Yes, ma'am.
Fine. Now, if it is clear, I think I told you as because we have already seen in our data analysis toolpath, we are not having this particular test availability there. So what you need to do, you need to go or you need to depend on the functions, and functions are requiring or asking you to provide the frequencies or the range of the frequencies. So what you need to do, you need to prepare your contingency tables. So I hope this format is there in your sheet. If not, I'm expecting you to make this format. Is it fine? One variable I'm taking in a row named as wealth status, person is wealthy or not, middle wealthiness, and the poor, and whether the person is having the graduation or not. So yes and no. And then row total and column total we need to write. I hope it is clear.
Yes, ma'am.
And I don't know, I think I forgot, I have provided you this particular format or not in this sheet?
Ma'am, we have only the observations.
No, ma'am, it's not given.
Observed count, this format is not given, so expecting you to please make it. I think it's very small. You can write these 3 categories, write 2 categories, row total, column total. And I think everyone knows how to make table. You go to this and put the border. Right? Done?
Yes, ma'am.
Done. So copy this and paste here. In the copy only, you need to copy this section only. So copy only this section and paste here in the second or in some other blank place to make the contingency table for the expected count. Done?
Yes, ma'am.
What about others? Everyone is ready. Shall I proceed to tell you the count now? Yeah. Yes. May I go ahead?
How to
Yes,
make that
ma'am.
column?
Which column?
Like the darker lines.
No, you do not need to do that. You make it only blank right now.
Okay.
After
fine.
that, I'll tell you. Do not do anything. Keep it blank only, the white one only.
Okay, fine.
Yeah. Now, we will see, as I think we have mentioned here, all the categories. Now, you need to count the person who are wealthy and they are having the graduation degree also. Means those who are graduated and they are having the wealthy status. So, how many are there, right? So, what you need to do, I think already you can see there is a drop down available. This is the filter, right? So, click on this. You would be able to see a drop down. Here, I'll click on the select all and I will only select the wealthy. Done?
Ma'am, there's no drop down in our sheet.
What about others? But I think filter everyone knows how to do. You can go to the home tab and at the right side you can find sort and filter. So you can use this filter here. That way you can get that drop down. I don't think so. I think everyone is knowing how to use filters. Yes?
Yes.
Yeah. So after using that, you can click on the drop down, select all. You can click on the select all. All the categories will be deselected. Only you need to select the last one, which is wealthy, and then click on OK. Till here, everyone is with me. Shall I go ahead?
Yes, ma'am.
Now in the graduate, again click on the drop down, select all and select yes. Okay. So wealthy people and yes. So you can select one of the column and you can see the count is coming as 6. Right? Visible, I hope. Bottom 6. So I'm putting here 6. Clear to everyone? Yes. My screen is visible properly.
Yes, ma'am.
Are you able to see my drop downs?
Yes, ma'am.
Okay. So I think the count of wealthy and yes.
Drop downs are not seen.
Yeah, that is what I'm asking. So the some of the people are maybe confused because of that also.
You're clicking that arrows coming after that. No drop down is coming.
Now you can see it is visible.
Yes, ma'am.
Yeah. So what I did, I have selected here the wealthy. I pressed on OK. And the graduate, I deselect all and I selected only yes and click on OK. So I got the count. I selected this and in the last, in the lower bar, you can find the count is coming as 6. Done. So I have kept here 6. Now in the wealthy and no, instead of yes, I'll select no and I'll do OK. So I can see the count is coming as 5. Done. Here.
Yes, ma'am.
I have written here 5. Then coming again here and instead of wealthy, I'll select now middle and click on OK. And in this, I'll select only yes. So those who have understood the process, they can wait. I'll do the counting easily or maybe little fast and then we'll go ahead. So yes is no and no is 7. So it's 9 and 7. So I'm writing here it's 9 and 7, right? Lastly, I need to only select the poor category. And in the graduate level, I'll select one by one yes and no. So yes count is coming as I think 5, yes. And no count is 6. Yeah, it's 5 and 6. I hope not tough. Everyone is getting how to do this.
Yes, ma'am.
Now column total. So it is very small figures. If you wish to directly count or sum, you can do that, or else you can use the sum function and then you can get the total. So the column total, first column total is 20. Similarly, I can drag it to the next cell. It is giving me the second column total. And this is because here it is 0. So it is coming 0. Moving ahead, talking about the row total, putting the sum, selecting these two. Done. And then dragging it. I hope it is easy to do, not tough. Everyone has done this. Any problem? Yes. Please be interactive. It's very difficult to understand otherwise. It is clear or not?
Clear.
Shall I proceed?
Yes, ma'am.
Yes, ma'am.
Okay. Now you need to get the expected count. So please listen very carefully. Already I have written here, or I already show you that E is nothing but it is row total into column total divided by grand total. But how many E are there? Total 6. For 6 observed frequencies, you need to calculate 6 expected counts, right? So that means if I will come here, so this is a value of first row and first column, right? So that means I need to calculate E11. So for E11, what you need to use? You need to use row total of first row and you need to use column total of first column and this will be divided by grand total. Getting my point? Similarly, if I am writing E12, Meaning is what? I'm talking about row total 1 multiplied by column total 2 divided by grand total. So whatever the value of the E, or what is the position of the your particular observed count, for that for calculating the expected count. Means for this 6, I need to have the expected count. So, and this 6 is lying in the first row and first column. So I will take the row total of the first, column total of the first, and the grand total. This 5th is lying in the first row, but in the second column. So first row total and second column total divided by the grand total. I hope concept is clear. It is very, very similar to the matrix and all. If you have studied matrix in the maths in the school time, it is clear.
Can you tell that with values?
Sorry?
Can you tell that the RT1 and CT1,
That
the
we
GT
calculate
with
here. That
values
we will
value?
calculate here, madam. We need to calculate these things here.
Okay,
But I
fine.
told you what is the logic behind that, right? So once I will come here, it is Valdian, yes. That means for this 6, I need to calculate. So what I'll do, I'll put a equal. So this is the row total multiplied by column total divided by grand total. Clear?
Okay, ma'am. Fine. Clear.
Right? Shall I enter? Everyone, shall I enter it?
Yes, ma'am.
Okay. Similarly, no means I'm calculating for this 5. So this 5 means I take this row total multiplied by this column total divided by grand total. Please check clear or not. Now check. Done? Shall I enter?
Yes, ma'am.
Now for middle means I'm talking about this 9. So this 9, 16 and 20, right? So I'll put equal. I'll take the second row total. I will multiply this by the first column total divided by the grand total. Clear? Only see the 9 and see its respective. So corresponding to the 9, row total corresponding to the 9, column total divided by grand total. Clear? Done? At least say something. Otherwise, I am thinking like you people have performing.
No, we are doing actually.
Yes, ma'am.
Okay. Now for this, I'm calculating for 7 now. So equal row total, its column total divided by grand total. Then for poor, it is row total multiplied by column total divided by grand total. For the last value, which is 6, that is row total, column total divided by grand total. Everyone, please check. Everyone is getting the same figures.
Yes, ma'am.
Everyone, shall I proceed now?
One second, ma'am.
Yeah.
Yeah. Ma'am, just show the Excel sheet, ma'am. Thank you, ma'am.
Okay. Once you are ready, please tell me so that we can proceed.
Yes, ma'am.
Fine. So now we will calculate the p-value. The p-value is CHISQ.TEST. This is the function which you need to use. Now, provide the actual range. So you need to select this portion only. That is the count portion and don't go in the total one. Right? So you need to only select this portion for the actual count, and expected count you have just calculated. So this is you need to provide only. Please check. Done. Shall I enter? Shall I enter?
Just wait,
Yes,
ma'am.
ma'am.
1 second.
Okay.
Yes, ma'am.
Fine. So you please check. Are you people getting this answer?
Yes, ma'am.
So we can compare it with our level of significance, which is
Ma'am, can you
supposed
show once how it came a p-value? How to do?
P-value is greater than.
it's the selection of your observed count, comma expected count. Done.
Yes, ma'am.
Okay. So if it is clear, we can see this is the greater than 0.05. So you need to accept your null hypothesis, which says there is
No
no
association.
association between wealth status and graduation status. Means graduation is not playing any role in deciding the wealthiness status of a person. This is the meaning. Clear? Yes.
Yes, ma'am.
Okay. Now you can use these two functions if you wish to get the critical and the calculated value of the time. So do we need to calculate or it is fine? Yes.
This is fine for me, ma'am. Rest is with others.
Okay. What about others? Do I need to calculate the calculated and tabulated value also of chi, or it is fine?
It is fine, ma'am.
It is fine, ma'am.
Okay, fine. Okay. So friends, if miss, I need to tell you, those who are interested for that, one thing I need to tell you. Here, if you want to calculate these two things, you need to keep in your mind that the degrees of freedom will be here, this. That is row, number of rows -1 and number of columns -1. So in our case, you can see in the contingency table, we are having total 3 rows and 2 columns, right? So what will be your degrees of freedom? It will be 3 minus 1 into 2 minus 1, which is 2. It's 2. Okay. You do not need to add. This is in the multiplication. Okay. Okay, fine.
Yes, ma'am.
Fine. Now, I will summarize the session if it is all I discuss is clear, right? So I think we have seen our null hypothesis is accepted. That means we are saying these two attributes are not associating with each other. This person is whether graduated or not. There is no say or this thing is not playing any role in deciding his or her wealthiness status, right? So I'll summarize the session on a note that today we discussed the conceptual aspect of chi-square test, but before that we understood the concept of non-parametric test, which is based on the categorical data and not considering the normal distribution of the data. Then we understood that chi-square test is one of them. And in chi-square test, generally we are interested in the uniform distribution of the frequencies. Chi-square test is having two types or two categories. First one is the goodness of fit. Second one is the independence of attributes or test of association. Right? So when I say the first one, which is goodness of fit, in case of goodness of fit, we are dealing with the single categorical variable with the multiple categories. And we are interested to see whatever is the frequency count coming for all the categories, whether it is equally distributed for all the categories or not. So the simple meaning is that we want to compare expected and the observed count, and we want to see whether the expected count is same throughout all the categories or not. So this way we are making the hypothesis. Very simply, there is no significant difference in expected and observed count, right? So degrees of freedom will be n-1. Expected count in case of goodness of fit, I told you it will be nothing but it will be the average of the observed count. Then we discuss the second category of the chi-square test, which is the independence of attributes or test of association. There we have seen we need to see that whether the two attributes of any object is independent or are independent or not, right? So in this case, there is a role of contingency table, as especially in case of Excel, it is very important to understand that contingency table will be the two-way or cross-tabulation of your data. So in the two different variables or on the basis of the categories of the two categorical variables, you need to write the count. So you need to go for using the filtering. So I think I told you, you can select your column and you can come here and you can select this filter. So once you will on this filter, you will be able to see the drop down. So you can click this drop down according to the preferences of your categories or making your combinations. For example, here wealthy and yes, wealthy and no, middle yes, middle no, poor yes and poor no. These kind of combinations you can make in both the columns and you can see the counts, right? That count you can fill here. You can get the total of the row and the column and the grand total. Once your first contingency table, which is for the observed count, is ready, you can make this table very easily if you are knowing how to calculate the expected frequencies. So the formula I have already given you. Only thing is that you need to keep in your mind for which element you are calculating the expected count. So whatever element you are considering, you can see whatever is its respective row total and the column total. That will come in the numerator in the multiplication. You need to take the multiplication of both and you can divide this by the grand total, right? So that way you can complete your this table, and then using the chi-square.test function, you need to provide the ranges of your both the frequencies to get the p-value. And rest is very easy. You can compare it with your level of significance. You can decide upon whether you are accepting or rejecting the null hypothesis, right? So friends, this is all from my side for the day. Now the forum is open for the questions and answers if you are having any. Yeah. Any questions, friend? I hope you are listening to me. Any questions?
No, ma'am. Stay.
Okay. Thank you so much, Pushpa ma'am. Any other person? Having any doubt?
No, ma'am. Thank you, ma'am.
Thank you so much, ma'am. Okay. So in the case, if you're not having any queries, we are meeting tomorrow. And from tomorrow, we are starting with the inferential statistics, right? So we will discuss firstly the t-test and all the combinations of the t-test, right?
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Yeah. Thank you, everyone. Thank you so much, sir.
Thank you, ma'am.
Yeah, thank you, ma'am. So, sir, shall I leave now? Yeah, thank you so much, sir.
Good night, ma'am.
Yeah, good night. We are meeting tomorrow.
Ma'am, someone has raised a hand.
Okay, I'm here. Yes. Any questions? Any query?
Someone raised a hand.
Okay, I'm here. Yeah. Who has raised the hand? Do you know,
Akshata Das.
Akshita Das. Ma'am, any query?